Hi everyone. Welcome to the review. This will be an overview of starting Unit 6. So for this week, you will hopefully watch the 6.1 through 6.6 College Board videos, and then also start on your Unit 6 progress checks for multiple choice and IQ. But in this video today, we are just going to go over the 6.1 and 6.6 topics. So to get us started, Unit 6 is the energy unit. So luckily, we focused a lot on that during quarter 2. So hopefully this is somewhat of a review. So here's a cute otter saying, "You ought to know you're amazing." I know, cheesy. Okay, so we'll start with renewable energy and non-renewable energy resources, and then we'll end with nuclear power. So let's start rolling. Okay, so very basic concept they want you to know is that non-renewable energy resources are these 4 things. So oil, coal, natural gas, and also nuclear, which we didn't really talk about as much in quarter 2. But basically non-renewable energies, they cannot be replaced at the rate that we consume them. Y'all know this. And then on the other side, we didn't get a chance to look at these either, but we have solar, hydropower, biomass, wind, and geothermal. And so these can be replaced during our lifestyle, so it's our lifetime. So we're never going to like run out of them, right? Okay. So obviously one is more sustainable than the other. So I wanted to show you this pie chart real quick, and it's basically where the US's energy comes from. So you can see here, let me get my pointer out. So you can see here that petroleum takes up a large chunk of how we get our energy. So does natural gas, and then coal and nuclear power take up a sliver, and about equal parts is also from renewable energy. So we are by and large powered by fossil fuels and non-renewable energy sources right now, or as of 2018, I should say. Okay, so, but to be a little bit more optimistic, over time we have moved away from certain things. Like we have definitely cut back on our use of coal over time, which is huge because coal, remember, burns the dirtiest. Our use of natural gas has come up, and then you can look and see where nuclear, hydro, wind, and solar land. So this is just in the US, which is different than in like on a global scale across the whole world. So global energy consumption looks a little bit more like this. So between the 90s and then what is projected into 2040. So as of 2015, they projected that this is where we would be at in terms of consumption. So you can see the world still really heavily relies on petroleum, increasingly so, including natural gas. The hope is that it remains constant for coal. I'm hopeful that maybe it'll decrease for coal. And then also very hopeful that renewables will become more available, the technology will get better so that more and more countries use it. And you see nuclear is projected to be pretty constant. So that's global energy consumption. So that begs the question of like, why is it that fossil fuels started to become a thing that we rely on? And so basically, before the mid 1800s, which is fairly recent, like biomass such as wood or like manure or dung was the main source of energy for heating and cooking. So however, it takes a lot of land to grow trees for wood. And so as the world's population expanded, we were running out of land for those trees. So in the mid 1800s, that's when fossil fuels started to become the energy source for us as a species. Okay, so there's different fuel types and uses. Oh, my animations, it didn't come through. But essentially you have all of the non-renewables are coal, oil, natural gas, and nuclear, and solar, wind, biomass, geothermal, hydroelectric, and tidal are renewable. and so we'll go into more of that as the sections we're on. So we'll talk about the non-renewables today, focus on those, and then we'll talk about the renewables next week. All right. Okay, and then another thing that the AP test really wants you to know, which we covered in Q2, but I'll remind you, is that like all of these natural energy resources, so mainly the non-renewable ones, they're not like distributed evenly across the world. And that has to do with a lot with geology and how the earth was formed in particular locations. But if you're looking at this map here, you'll see that all of these different colors represent different like natural energy sources that are found where. So you can see yellow is oil. So you can see here, there's a lot of oil in here, also in the Middle East here, oil definitely in Siberia. So that's where there's a large concentration of oil. Natural gas, you'll see huge concentration of natural gas in like Siberia. Again, some in the Middle East, and then spots in different parts of the world. You can see where coal, there's a lot of coal, especially concentrated in China and the US. And so that makes sense as though right now, China still has a large reliance on coal. And at one point in the pretty recent past, the US had a pretty large dependency on coal, but we're trying to move away from that. And then you can see where the spots there are uranium, which is what nuclear power is dependent on. Okay, so that shapes geopolitical, like, you know, climate around energy and trading and mining and whatnot. So that's an important thing to keep in mind. Okay, so there's a whole section that wants to talk about fossil fuels, which y'all already know a lot about based on Q2. So I'll go over the couple of things in that the AP test wants you to know that I didn't necessarily touch on. So one of which is how a power plant works, particularly a fossil fuel power plant. So we're going to use coal as an example, but most power plants are set up in this way. So there's like some sort of resource. So right now it's coal. So coal is supplied and piped into the power plant. And what happens is it gets put into this really, really hot chamber of sorts called the boiler usually. And the boiler usually has these coils of tightly coiled coils of water that run through it. And so obviously, as the coal is being heated, it's producing energy and thus heating up the coils and then evaporating this water. So then you have all of this water and gas form, steam. So then all the steam is being piped through, and it gets piped over to the steam line. So the steam line then pipes steam over to the turbine. And so what happens is that steam, as it gets piped in, it starts turning that turbine. And by turning the turbine, it runs the generator. So then that's how eventually how coal powers that generator to create electricity or create energy that we use. Okay, so that's power plants. And then also I want to talk about real quick, something they want you to know is coal-fired steam engines. And coal-fired steam engines work in a very similar way. It's also like, you see there's a bunch of combustion happening here. So coal holds energy via its chemical bonds. And so when that's released and there's water nearby, it creates steam. And that steam again goes and, you know, powers the piston in order to move the crankshaft. So obviously coal-fired steam engines run on coal. And then it's the same technology used in like the power plant factories. But it's gradually being replaced by natural gas, which is a win, which is great. The other mechanism that they might mention in the test that's important to know is the internal combustion engine. So this one is different. It doesn't run on coal, it runs on oil. So this is in all of your cars, motorcycles. and that is a different mechanical engine. All right. Oh, okay. So the last thing about fossil fuels is that scientists are able to project based on, as we learned in unit 5, scientists are able to project based on reserves. So if you remember the reserves from mining, we're also able to predict how much reserves there are in coal, natural gas, and oil. So based on the number of reserves there are, they're saying that coal, you can probably get another like 100 or so years out of it. However, based on the number of reserves our natural gas has, only about 52 years left with it before we're out of natural gas. Because remember, it's a non-renewable resource. And same with oil, where we're projected to run out of oil in about 50 years. So that's why you have car companies like GM right now. Like GM just came out, which is a huge car company, but GM just came out with a pledge that they plan to be like fossil fuel free by 2035. So they want to turn all of their cars into electric cars by 2035 and then be carbon neutral by 2040. So the car companies are seeing this coming up, and like I'm sure they also want to be more like ecologically sustainable, but in order to be economically sustainable, they have to start switching to alternative fuel sources, such as electric, right? So, okay, so to touch on the very last like energy resource is nuclear power. And so nuclear power, like even though it burns so much cleaner, so much cleaner than all of the fossil fuels, it's still considered non-renewable because we just don't have enough uranium to use it forever, and it doesn't regenerate at a rate at which we use it. So the nuclear power, like what is this is it's powered off of uranium, which is mined, and so it contributes to climate change in the form of it releases a lot of water vapor, which is a greenhouse gas, but it doesn't release carbon dioxide or methane and all of that. And it is much cheaper than coal to run this power plant. So that's something to keep in mind. All right, so that was first half of Unit 6, which hopefully was pretty painless for y'all. So this week, starting on the 3rd to the 10th, I want you to, it is in your best interest to watch this video, which you already did. Also try to watch the AP College Board 6.1 and 6.6 videos because they'll offer a lot more detail, which is important. And then also finish any relevant questions on your Unit 6 progress checks, multiple choice questions, and FRQs. So you should be able to finish about half of them, and then the other half you should be able to finish after next week when we finish up Unit 6. All right, thanks for watching. Definitely message me if you have any questions and get in touch, all right?